Alright, this is VLANs, and we started talking about initially in class. We reviewed, we talked about VLANs in general. VLANs in general. And then my question initially was, what do these effect do they have directly on VLANs? Well, we talked about VLANs. We did this example here. We've got some red VLANs on both sides. In order for that to communicate, they have to go through the trunk. And they'd have to put the correct VLAN tag on the frame. And so we went through that process and reviewed that and talked about that the same way. If these blue ones are going to communicate, then that would be the blue VLAN tag go across, and then they would connect to the ports over there through that trunk. Now, dynamic trunking protocol right here, really, this would still all work, but this just makes it easier for the trunking to take place between a couple Cisco devices. The same thing here, sharing VLANs between the devices. We're able to use this technology in order to make it easier for the VLANs. If you changed them here, then those could migrate to your other switch. And we did those examples and talked about that. But those are things that make managing VLANs and trunks maybe easier, but they don't have to be there in order for the VLANs to operate. We kind of gave a similar, we're trying to move data through routers, and routing protocols do a great job of helping the routers build their routing table so that the actual data can be moved through the router. Okay? Alright. So let's take a look here. We started talking about VLANs and relating it to inter-VLAN trunking, being able to move from one VLAN to another. So let's look at this example. That would be over here on the right. Right here, in which we have a router, excuse me, and then as an example we talked about this blue VLAN. We could connect that blue VLAN to the router. This would not be a trunk. It would be from a blue VLAN port to the router port, and that router port then would have to have an IP address on that particular network, whatever VLAN that was. Another example, you could go from a red port to the router, and that would have to have an IP address on that particular network. And the same thing would be true for that green one. Now, as you increase VLANs, it would become pretty obvious that's not going to work very well on the router. It does not scale very well. Plus the physical issues of hooking everything up and assigning them. So what we can do is we can have a trunk in which we can encapsulate the frames with the correct VLAN tag. And what we can do then here, for example for the red one, we have a VLAN 10 here. We can create here a sub-interface. Here's an example. I created this sub-interface .10. This number doesn't have to be the VLAN number. What has to be correct would be over here. We have to give the encapsulation before we give the IP address. And so we can indicate that this is going to be VLAN 10, which is this VLAN over here, the red. And then we can assign to it an IP address. This IP address will end up being the default gateway for all of the PCs that are on this VLAN, this red one as an example. And then what happens is the switch literally sends, the frame goes in here, the frame goes to the one physical MAC address in the router. But the router then can look at the frame and see, for example, that the encapsulation is that this is on VLAN 10. Okay. It's going to then it's going to use the IP addressing to determine where it's going. It's going to look up in its table. It's going to strip all the VLAN stuff off. Look at the IP address, see where it's going, go ahead and queue it up and send it out. Now, if it's going to, for example, if it's going to the green network, this network down here, it'll queue it up to go out the same interface. And when it comes out that interface, it's going to go ahead and encapsulate it, or actually tag it, if you want to think of that. It's going to tag it with that green VLAN number. And so now it can come down and it can actually go to a PC on that green network. And of course, you'd set up the same thing for the blue. So we can do inter-VLAN routing inside this router. I finished up with some comments about what would happen if we stuck another switch on there and we put a VLAN 10 on that switch. That VLAN 10 up here would have no relationship to this VLAN 10 except for the fact that we're using the same number. Because if you would ever communicate between those two, since this is a router port, this would be a separate network than any of the networks on these sub interfaces. You couldn't have the same network on two sides. So that would have to be on a different network. So in reality, when anything comes in from there ends up into the router, all the VLAN stuff, the tagging is stripped off, the MAC addresses are stripped off. He looks at the IP, sees where it's going, and then if, let's say it's going to the red, when it goes out this interface, it will tag it with that red number, so when it gets down here, it can literally get to the red network. To the ports that are in the red VLAN. Alright. On Thursday, we'll talk a little bit more about how would this work in a multi-layered switch. We could turn on IP routing in that switch. We can take routes and ports can be switch ports, or we can say no switch port, which would make a port a router port. And we'll look how that works on Thursday. So that's enough for this. We're done.